All right, section 12.1.2, we're talking about right triangle trigonometry. So it's still sine, cosine, and tangent, but now we're going to actually use those things to find side lengths of triangles. Quick review of sine, cosine, and tangent. Sine of angle x equals the opposite side length over the hypotenuse length. Cosine of angle x equals the adjacent side length over the hypotenuse length. And tangent of angle x equals the opposite side length over the adjacent side length. And of course, we talked about SOHCAHTOA as a good way to remember the three trig ratios. Here's our first example. We're being asked to find x and y. Now, when you are given a triangle, what they give you and what you're being asked to find will determine what trig ratio you use. So let's start by finding x in this triangle. We always have to start by choosing an angle to start from. We remember from yesterday that we never start from the right angle. So exclude that as a possibility. So we could start from the 20-degree angle, or we could start from this angle because we could actually find the measure of that angle because the three angles of a triangle have to add up to 180. But why do that extra math when we already know that the angle in the bottom left corner is 20 degrees? Let's just start from that angle. So if we're starting from this angle, we are being given the opposite side. And if we're finding x, which we are first, we're trying to find the hypotenuse. So we choose the trig ratio that is opposite and hypotenuse. And that's sine. Sine is opposite over hypotenuse. So we set up our trig ratio. The sine of the angle, which we know is 20 degrees here, equals the opposite side length, 410, over the hypotenuse, which is x. Now we have a simple algebra equation that we can solve for x. When we look at this equation, the x is currently in the denominator. So we need to get it out of the denominator so that we can solve for it. We're going to do that by multiplying both sides of the equation by x. Now on the right side, the x's will cancel out, and that's okay because x is now on the left side of the equation. We have x times the sine of 20 degrees equals 410. The sine of 20 degrees is just a number. If you punch it into your calculator, you'll get a decimal. Okay? It's just a number, just like 3 is just a number. Just like 5 is just a number. Okay? We cannot separate the sine part from the 20 degrees part. It is one thing together. All right? So, in order to get x by itself, we're going to divide both sides of the equation by the sine of 20 degrees. On the left side, the sine of 20 degrees on the top and the bottom will cancel out, and we'll be left with just x. On the right side, we have 410 divided by the sine of 20 degrees. We can plug that right into the calculator. Before we plug into the calculator, we have to double check the mode. Hit the mode button on your calculator. Go down to where it says radian and degree. You must be in degree mode. The default on the calculator is radian mode. So if you change your batteries or you clear your memory for some reason, the calculator will go back to radian mode, and it will read this 20 degrees right here as radians, and it'll give you the wrong answer. So make sure that you are in degree mode. Now go back to your home screen and let's type in 410 divided by the sine of 20 and hit enter. And there's our answer. X equals 1,198.8, and I think our units are in feet here. Feet. So a second example. Oh, actually, wait, we need to go back. Well, no, we'll just do this one. We forgot to find y in that previous example, but we can find y here. So we're given this triangle. We can see that we have angle B, which is 43 degrees. We have side BC, which measures 20 centimeters. Let's find side Y. Which trig ratio are we going to apply here? We have this angle. Side Y is opposite. The side we're given is adjacent. So we're going to use the tangent because tangent is opposite over adjacent. So we do the tangent of our angle, which is 43 degrees, equals the opposite side over the adjacent side. Again, we have a simple equation that we can solve for y. We need to get the y by itself. Right now it's being divided by the 20. So we're going to undo that division by multiplying by 20. The 20s on the right side will cancel out. That'll get our y all by itself. And on the left side, we have 20 times the tangent of 43 degrees. So we can plug that right into our calculator. 20 tangent 43, and we end up with an answer of 18.7 centimeters. All right, let's find x. There are two ways to find x now. Since we just found y, we could apply the Pythagorean theorem. And we would have 18.7 squared plus 20 squared equals x squared, because that's our hypotenuse. To solve for x, we'd take the square root of both sides, and we'd plug that into our calculator. Square root of 18.7 squared plus 20 squared. And we'd get x to equal 27.4 centimeters. Or we could use trig ratio again. And we, in a sense, could be starting from the beginning and say, all right, let's start from the 43-degree angle. If we want to find x, so we have this angle, we're trying to find x, that's the hypotenuse, and we know the adjacent. Adjacent over hypotenuse is cosine. So we could do the cosine of 43 degrees equals adjacent, excuse me, not x there, adjacent over hypotenuse. And now we would solve for x. We would multiply both sides by x. The x's would cancel out. We'd have 20 left over there equals x times the cosine of 43 degrees. Cosine of 43 is just a number. If we want to get the x by itself, we divide both sides by the cosine of 43 degrees. The cosine of 43 degrees cancels out on the left, leaving us with x all by itself. And now we can plug 20 divided by cosine 43 into the calculator, and we get 27.3, in this case, centimeters. Now, one important thing to point out, notice that over here we had 27.4 centimeters, but over here the rounding was just a little bit different. It gave us 27.3 centimeters. That's because when we used the Pythagorean theorem, the 18.7 that we were using was a rounded number, so it was an approximation. So our answer of 27.4 is just a little bit of an approximation itself. The 27.3, it's an approximation because we rounded it to 0.3, but it's a more exact approximation. Both answers are acceptable. As long as you're showing your work, you get full credit, and neither one is more correct than the other because the processes are both legit.